Okay, so here we go. Let's start the webinar. Securing data is a four-letter word. It's about the next generation ABAC-powered data-centric security. I hope that you have guessed what sort of figure it is we have in the middle there. If not, it is a diamond. So, as always in our webinars, you are centrally muted. The webinar will be recorded, and the slides will be available for download afterwards. During the session, you can ask questions in the question box in the GoToWebinar client, so please feel free to do so. And here today, I have my dear colleague David with me.
Hey, hi, everyone. Good morning, good afternoon. Welcome.
And David will be doing a demo for us today. So we'll have a brief introduction and discuss the area of data-centric security, the business drivers for it, the technology solutions that are around, and then we'll focus on ABAC and how we use attribute-based access control in the realm of data-centric security. Right, David?
Absolutely.
And the demo will be, I think, quite fascinating.
Yes, indeed. We'll look at how insurance companies can use this technology to secure their sensitive information.
Right. Good. So, but before we go into the demo, a few things about the background. So, this image that you see here, those who have attended Axiomatics webinars before have probably seen it before, because I tend to like it. It represents what we very often recognize when we talk to customers around, namely that the good old data centers are gone, and today instead we have a fairly mixed environment with private clouds, public clouds, very mobile users. So if we think back 15 years ago or so, the big B2B thing started, and every company with some self-respect needed a portal where they could talk to other companies. Long gone are those times, because today all companies have their own representations online in the cloud. They may even present entire APIs of themselves. So we should talk rather about B2 cloud to be today. And they talk to one another via third-party clouds as well. The users are all around. They go wireless, and then mobile. They do all sorts of communication via mobile devices. They even perform business transactions online. They do it all the time, around the clock. They store data, and this data actually goes all the way down into the infrastructure on service, in the cloud or on-premise, wherever. They even perform financial transactions, buy things and the like. Anything to add, David?
So we end up with a relatively foggy world, which is quite fitting for cloud computing, I guess.
Yes, indeed, yeah. So the new normal then has to do with global connectivity, collaboration, and mind you, collaboration across organizational borders. Line of business is no longer necessarily sort of the boundaries within which you collaborate and share information. You do it globally as well. Mobility, data sharing, cloud, big data, all these things are challenges. And what we'll talk about today is very much how do we, with all this connectivity, protect this jewel that we have within the database at the core. So how to protect confidentiality in this new landscape.
Right. So we're seeing on the one hand the business world becoming even more flexible, even more dynamic, and the legal world becoming stricter with how you handle privacy, confidentiality of the information, sensitivity of the information.
Indeed, yes. Yeah. Mm-hmm. So the question is, so the answer then to how to protect confidentiality in this new landscape, the first answer you could give is, well, we don't. So this is an interesting thing. At the recent Identity and Access Management conference in Gartner conference in Las Vegas just last week.
Correct, 2 weeks ago.
2 weeks ago, Greg Kreisman predicted this. By 2020, over 80% of enterprises will allow unrestricted access to non-critical assets. So basically, what this implies is that the collaboration, the information sharing is so important that we see this trend where organizations say, let's reduce any thresholds to make sure that people collaborate efficiently. So it's an enormous pressure. The sharing and the enabling of information sharing in collaborative workflows is so important that companies try to remove identity and access management where possible. So that's what this says.
Correct. Many businesses would rather share information and do business rather than withhold information and not do business.
Right.
But as you'll tell us, Finn, this is not always acceptable.
No, of course. Then we have the situation. How about critical assets? So this was for non-critical assets, but obviously there are critical assets. And then again, this year at the Gartner conference, Gartner analysts repeated the prediction from last year that we are seeing attribute-based access control becoming the dominant mechanism to protect critical assets. So that is sort of the way to go. So the traffic light will indeed have stop signs in there, right? And this is very much aligned with what we're thinking, right? Because we do base all our authorization then on attribute-based access control. And today we said we were going to look at this from the database perspective, and that is for a good reason. If we look at the breaches out there, they focus strongly on databases. Let's look at a few figures. So the average cost to company for data breach is 3.5 million. The average cost for a single successful cyber attack, $300,000. We have not invented these figures ourselves. They come from the Poneman Institute, an IBM report. We have more other such figures. 94 million is the estimated number of citizen records that were lost. So these are privacy breaches in the US alone, right?
Correct.
And this was sort of the average cost to the sum total of,
which makes 18 billion. The price is right and very hefty.
Yeah, yeah.
And if you're interested in more figures and more data breaches, you can go to a website called Information is Beautiful. They have great graphics that illustrate the number of breaches that have happened over the years. And do not underestimate the problem. It is something that happens every single day with very hefty fines at the end, very expensive activities.
Yeah. Now, David, I think it's fair to say that we do not promise to save customers all those 18 billions, right?
1 billion is enough.
Well, yeah. So the solutions that we're going to talk about now will not necessarily sort of cover all these various breaches, because from a technical point of view, there's a certain breadth in the intelligence used by criminals to get to this, but we certainly do cover a good portion with the solutions we're going to talk about today. So behind this this new sort of agile business, we see how needs emerge on new security around databases. If we look back, if you look in any good school book on how to establish good governance on your databases, these things, like we see here, typically come up. Make sure that the default user accounts are changed on the database. No Scott in your Oracle database anymore. User and roles needs to be well defined. No exposed passwords, and so on and so on. All of these measures typically focus on securing the database container itself, sort of to put a firewall around it, and not on this list are then also the database firewall tools that, for instance, protect against SQL injection attacks and those sort of things. What we conclude is, with this new agile world and global connected world, that is not sufficient. We need to do more.
Right.
It's essential, right? You cannot do without this. We have to have this as well.
These tools are the foundation for a secure database, but it's not enough to enable secure sharing of your data in the contextual, in the dynamic world that we live in. And that, Finn, I believe, is what we'll be focusing on.
Right. So, yes. So the switch then, the next generation of security tools that we've seen, we call data-centric. So what they do is they focus on the data rather than on the database. And typically, I would say this has primarily been driven by, for instance, PCI, the payment card industry's regulations, or privacy regulations around social security numbers and the like. So we very strongly focus here on sensitive items within a database, for instance. And technologies in here, for instance, tokenization. In this case, in this example, we have a database that contains a number that we need to protect. The token that we replace it with is sort of similar, but it's a different one. The token can be used to go, of course, and retrieve the original figure from some store, but the end user does not get to see the real value.
Right.
So that's one way. Another way that we see is encryption on the data element level, sort of, where you simply render it unreadable somehow. And lastly, of course, data masking. Data masking, I don't know, David, if the example that we have here is typical. In this case, we have a John Adams who was born on March the 13th, 1972, and we change on the fly. This would be dynamic data masking. We changed into a Pete Smith who was born on the February the 11th, 1972 instead. So if the application wants to do statistics on who many males were born in 1972, that would still work, but we have not revealed the identity of John Adams. Right.
Right. It's funny because I thought John Adams was born in the 1800s, but I might be mistaken. I want to add something else, Finn, a comparison, an analogy. You talked about database security, and now you're talking about data security and how data security is the next step forward. If you drew an analysis or an analogy, rather, with firewalls, the same happened 10, 15 years ago in the SOA world. It used to be that companies would have a firewall and they would lock everything, so nothing could come in. And of course, because businesses needed to connect more and share applications, share processes, share services, the whole SOA paradigm came along with XML gateways, with web services security, with secure REST endpoints. Right. And in a way, what we're doing here is the same on the data level.
Right. Yeah, that's very good. Technically, the analogy is clear. Yeah, absolutely. Now, if we look at these methods, it becomes quite obvious that the change that we need to do needs to be done both on the database side, because the database needs to sort of return some other data than before, but the application will have to be able to live with it as well. So if I'm the application and I query the database and say, give me John Adams, and I get the Pete Smith back, I had better sort of be adapted to live with this. Right. And we need to know that the logic of the masking, for instance, in this instance, is adapted to the logic of the application. So it's a quite cost-intense way of doing things. It requires almost always adaptation both on the application side and on the database side. And it's very strongly focused on the securing of individual items, like typically credit card, social security number, something very, very sensitive in there. It can hardly be generalized to entire databases.
Right, right. So here you're putting a couple requirements on the solution that we need to build. Right. It has to be transparent to the application. The application must not be impacted by this new way of securing the information. It has to be what I like to call unintrusive. You can easily configure it in. You can easily turn it off. And finally, another requirement that you just mentioned is it has to be generic enough to cater for any type of data that you're dealing with, not just a one-off example of data masking John Adams into Pete Smith. Very good points.
Exactly, yes. So then, this is good and important, and we can't do without it, mind you. We're not saying this should not be used, it has to be used, but it's not very flexible, and we need to extend beyond. So we now introduce the next generation data-centric security, which is driven by attribute-based access control, right?
Right.
So let's look at what that entails. So first of all, since it's attribute-based, we can retrieve attributes from all sorts of sources to define exactly who the user is.
Right.
We then use attributes for the context and for the data that we're looking at to determine what this user wants to do, where, when, why, how. And then finally, we have a policy that will determine permit or deny, depending on what is being requested.
So, Finn, these attributes, can they help describe devices or IPs or time of the day? Is that possible with attribute-based access control?
Indeed, yes. So, and the difference between our other attribute-based access control solutions and this one is, of course, that for those who are familiar with ABAC, the resource side is very much the database itself that is being protected, but the subject and the context can, of course, retrieve its data from wherever. Yeah.
And the fact that it's based on policies, does that have any impact? Does it help with the audit piece?
Yeah, of course, indeed, because we have externalized this. The other way to do that, and what we do today, of course, would be to have this logic inside the application. By setting this at a central point, we can sort of audit the policies, and we're absolutely sure that they apply to all the channels that come into the database, regardless of which application, which service, which BI tool, or what have you, so that it intercepts everything.
So it's fair to say that ABAC is giving us visibility into the authorization that we apply to the sensitive data we're handling.
Yes. Okay, so I've suggested we call this WYSIWAG, but all my colleagues thought this was very stupid because we don't need to wag our tails to do this. But what you see is what you're authorized to get. Basically, that's it. You query the database, you only get what you're allowed to see. That's it. That's the principle. So with the product that we're going to look at now, which is called the Axiomatics Data Access Filter, MD, where MD stands for multiple databases, we claim that we achieve more than 2 by adding 1 + 1. So what do? First of all, we take data-centric security technology, and very proven such technology, because the SQL proxy that we use in our solution is from one of the leading components in the data masking space. So it's been around there for many years. It's very robust. And then we add on top of that our own robust ABAC technology with reverse querying. And the result then is sort of a next generation database security toolset which integrates data access control with corporate identity and access management.
So I think I'd like to highlight the fact that it means that those authorization policies you define to control access to your data can also be reused in your applications, your APIs, your enterprise buses, in many different locations within the enterprise stack.
Mm-hmm. Yes, indeed. So absolutely. So, and this is a bit how it works. We have an application. The application sends a SQL query to a database. The query is intercepted by this thing in the middle. We call it, in this case, a SQL filter. It sends it off to an authorization service, and the authorization service then queries its policies. The policies may also need to motivate a lookup of further attributes. In this case, we have a user Bob who wants to see columns A and B from table T. And of course, the authorization service probably does not have a policy about user Bob. So probably we need to go and look, who is user Bob? What role does he have? What department does he belong to? What sort of other authorizations does he have according to our metadata around in different directories or databases in the company or in the cloud or wherever? So we retrieve that, and then finally we reach a decision on the side of the authorization service in terms of conditions which go back to the filter, which then has the ability to use these filter conditions to change the SQL statement on the fly. So we get select AB from table T, where, and then comes all the conditions.
So what I'm hearing is, number one, we will only retrieve entitled data from the database. So that's not only more secure, but it's also more efficient.
Mm-hmm.
And secondly, the filter is the SQL filter, the where clause, is dynamically generated on any number of fine-grained authorization policies, which in turn can use additional attributes about the user and the resource, and potentially a relationship between the user and the data.
Yes, indeed, yeah. With the resource, mind you, we need to be a bit careful because basically the resource is defined by the database we protect.
Correct, absolutely. Yeah. The row in the database.
Yeah. So let's look at the architecture of the multi-database solution. Is a bit like this. We have the SQL proxy that has the task of intercepting the call that comes into the database. So you see the application, the only thing we need to do on the application side is to configure it to go to a new listening port. So instead of going to the port that it used to go to, which was the database directly, it is now redirected to the SQL proxy, and we hide the database behind a firewall or something so that you can't access that anymore. And we intercept the requests. We go query the SQL filter service, mm-hmm. which in turn then uses its policies, XAML policies, actually, and then it gets the response and changes the SQL statement. And as a result, what goes back to the application is filter data. So that's sort of the architecture. And David, you will be showing this running live, but before that, let's go through a few slides that are aligned with the demo. The demo is about an insurance use case built actually on a real use case from a customer.
Right. Yes,
right.
Indeed.
This one, these slides are more intended to show the workings of this on a higher level. So the data, it's not exactly the demo database, but somewhat similar. So insurance companies, of course, need to keep track of their clients who have policies. In this case, we also have social security numbers and credit card numbers about our clients. So the attributes that we can use in policies around this can be divided like this. First of all, of course, the table itself can be an attribute. So we can use in our policies the table clients as an attribute. The column, like for instance here, credit card could be an attribute, or the row column value. We could say if you have this value within an individual cell, that could also be an attribute. Finally, of course, also the actions, which in the case of a SQL statement can be select, update, insert, or delete. These are things we use to build our policies, right?
So this means we can do protection at the table level or at the column level.
Mm-hmm. And of course, on the row level with the values.
Right.
Yeah. Good. So let's see some examples what this implies. So here we have a policy that says that if you're a manager, you can see clients, namely the table, but not the social security number and credit card columns. We have the user Greg Miller, who is a manager. He comes along and his application fires this query, or mind you, it could be of course himself if he's using a SQL querying tool.
Funny you should mention that. As a matter of fact, we're deviating a bit from the scenario here. But this technology applies so close to the database that it would apply whether you're accessing from an application, from Excel, as we'll be doing in the demo, or directly from the SQL utility tool.
Indeed, yeah. It is even in your demo environment. I think it would even apply to the
SQL developer.
SQL developer tool. Yeah, right. Okay, so this is the query that we send, and the result is this, right? We ask for first name, last name, and amount. But the policy said that manager can see the table clients. What we cannot see there are the columns social security number and credit card. We didn't ask for that, so we get exactly what we wanted. So as requested, we got this back, right? Now let's do exactly the same thing. Greg Miller comes along. This time he asks for first name, last name, amount, and the social security number. This is what he gets.
No records back.
Mm-hmm.
So in other words, you can only view an entry if you have the right to view all the fields in that entry.
Right. So the effect basically becomes row level, sort of, but it's fine-grained cell level on the condition.
Okay, right. So no backdoor. Great.
And this is also important for us to remember that this is an important aspect of this compared to the other technologies that we talked about, because if I have a legacy application that has been running for 30 years and I put the proxy between the database and the application, that application will not break because we do not change. So I mean, any application will be able to understand that it gets an empty data set on a query,
right,
but it gets the same number of columns. So it asks for fields, social security number, first name, last name, and amount. It gets those 4 fields, but an empty data set.
Right. So the contract does not change.
Right.
The input is whatever the input is. The output will always be the same, the very same output that the application expected.
Yes. So which makes it possible to use this technology behind legacy applications.
Right.
Yeah. Good. So we have one more example. The manager sees client, but only his own social security number and credit cards. We have Greg Miller again. Same thing again with 2 columns that are protected. This time we get to see this, because Greg Miller is the one who is asking, and Greg Miller gets to see his own social security number.
You know what? This is a great example of a relationship. We're checking in ABAC, in attribute-based access control. Here, we're expressing the relationship between the person requesting the information, Greg, and the owner of the information, happens to be Greg as well.
Yeah.
That's something that's very hard to implement, if not impossible, in role-based access control.
Yes, yeah, indeed. So then I think this is our final example here. So let's say now that Greg Miller is also a claims adjuster or administrator of some kind, and he's allowed to manage all the items from the UK. So then this statement, select everything from the table clients, renders this. Namely the items that have country equals UK.
Right.
And with this, David, let's dive into the demo.
Okay.
Live stuff.
Sounds good. Thanks, Finn. And the use case that we have here is still the same use case as the one that Finn was building on. We're dealing with Acme, the very famous insurance company, and they're building a new application. And at the core of their application, they have rich and sensitive data about their customers. And we envisage in this particular new application 3 types of users. We have customers, and they'll be accessing their own information via a rich mobile-friendly web portal. We will not be showing this today. We have brokers who sell insurance policies and manage the contracts on behalf of their customers. And we also have claims processors who are responsible for processing the claims that come in, checking their validity, approving the claims, and processing the payments. Now, in the demo, Finn, we'll be using Microsoft Excel as a way to visualize the information in the database. And we'll be playing the role either of a broker or a claims processor, and we'll see the impact of being one or the other on the data.
Right, and I think that is important to point out. So the choice doing this with this, because there is a real application that uses this as well, right? The database. So we have a demo application that is Java-based.
Correct.
But here we're using Excel to show that, which is sort of, I think, an important use case as well, right? Because by pushing the access control mechanisms all the way down into the database, there's no way you can bypass that. So typically, if you have the access control built into the application, which is very common, if you were to go via Excel directly to the database, you could potentially sort of violate security that you have built into the application. Here, that is not the case, right?
Right. Side technical note for this demo today, we're using Oracle 11g Express Edition. In terms of actors for the demo we'll be doing today, as I said, we'll not focus on the customer. We do have a Java-based web app, as been mentioned. We'll focus on the brokers and the claims processors or the claims managers. And the 2 types of objects we're dealing with are, on the one hand, insurance policies, on the other, insurance claims. The type of information we're dealing with are amount, social security number, region, customer financial information, whether a claim has been approved, so on and so forth, many different sensitive fields in that data. The demo architecture is relatively simple. You have a user. That user will log into their Windows PC. They'll fire up Microsoft Excel. They'll be able to view the rows of data. They'll be able to run some graphics to analyze that data. And the Excel in the backend will connect through ADAP, through the Axiomatics data access filter, to the backend database. Now, Excel, or any application, is not aware of the fact it's going through ADAP. That happens transparently, and that happens also through configuration. Okay. So the scenario we're using here is that brokers can view the insurance policies of a customer if the broker is assigned to the customer. Here's a very nice relationship. And if we analyze this sentence to go from the one at the top to the one at the bottom, you can, what I often say to tell my customers is pull out the highlighter and highlight the keywords. Brokers is a role attribute. In ABAC, broker will be the role. Okay? View is the action. You can relate back to the CRUD actions that you mentioned, Finn, before, create, read, update, delete. In this case, we're dealing with a select action. Insurance policies of a customer, this is the resource. So this will be a row in the insurance policy of our database. And then here we have a nice relationship attribute which binds the user, the requester of the information, to the owner of the data, or rather to the broker who is assigned to the owner of the data. In this case here, the relationship is user ID must be equal to customer's assigned broker. And if we rewrote the rule in using those building blocks instead of plain old English, we would end up with a user with a role is equal to broker, can do the action is equal to view on resources of type insurance policy if the user ID is equal to the customer's assigned broker ID. So In the demo, we'll show that if we change a user's role, an employee's role, the information displayed changes automatically, instantly. If we add more data to the database, we'll see the change in the Excel sheet as well. We can add a relationship between a customer and a broker to see that the amount of information changes as well. And we could also log in and log out and see what happens there. So I'm going to go ahead and open up my remote desktop, and I'm going to connect to my demo environment. And I'm connecting as Alice. And Alice, right now, is, I believe, a broker. So we'll check that in a second. Actually, let's check that now. If I go to my backend database where I maintain my users, you can see that my user, minimize that, my user Alice here is a broker. Great. If I go back to my environment demo, I'm logged into Windows 2008. You can see that my username is Alice here. And on the desktop, I have my Excel sheet. I'm going to go ahead and open it up. And I'm going to go to my insurance policies tab, and I'm going to go ahead and refresh all the data. Okay. In this particular instance, I will have to reconnect the database. There we go. And now you can see that I have in total 7 different records that I'm displaying here. These are all the different insurance policies that I, Alice, as a broker for those customers, can view. And of course, I can have some fun and display those insurance policies in a rich graphic to display perhaps statistics that you want to know about the insurance policies. In this case, they're grouped by the price or the value of those insurance policies. If I go to my insurance claims table here, though, there is no data. I can go ahead and try to refresh this, and sure enough, I cannot view any of the insurance claims. Sure enough, if you remember, the rule that we have that we saw on the slide, and I can pull it up again, says, my PowerPoint, brokers can view insurance policies, but we do not have anything about insurance claims. Only claims managers can view insurance claims. I'm not a claim manager. I cannot view the insurance claim. Okay? Well, then what happens if I change my user's role? Let's go ahead and change Alice's role in the backend source. This is what we call in ABAC a policy information point. Here, I'm going to make my Alice a claims manager. And I'm going to click Apply. Changes are sent off to my database. And I can go back to my demo.
David,
do you want to jump in?
Yeah, just a question, David.
Mm-hmm.
When you're in this tool that you're in now.
Yes.
That is the Oracle
SQL developer.
SQL
Yes.
developer tool. In this case, is that tool also going via the data access filter, or does it go directly to the database?
It goes directly. I have a backdoor.
Right.
I always have a backdoor.
Yeah. So, and that okay. Now that's important then to understand. So here
Yes.
you can change the raw data, whereas in Excel we see the effects of that.
Correct.
Good, good.
And in this particular instance, we're playing with the policy information points, so the metadata itself, not the data we're trying to protect.
Yes, very good. Thank you.
So if we go back to my demo, if I go to my insurance policies tab, I can just click on refresh, and you'll see that the data has disappeared. Sure enough, I am not a broker anymore. I am not allowed to view any insurance policy. What about the insurance claims? Can I view any insurance claims? Yeah, there you go. It refreshed automatically, and I can view insurance claims. And again, much like I could do some graphics with my policies, I can also do graphics with my claims. Let me refresh that table here. And now we can see the status of my claims. So I have 5 unapproved claims and 1 approved claim. So by simply changing my role, I view different pieces of data. That's not all. If we go back to my PowerPoint for a minute, I said add data to the database. And we'll see that the access or the range of values returned will be impacted or may be impacted. So let's go do that. Let's go to my claims table, and I'm going to right-click on this claim here, and I'm going to clone or duplicate the row. Of course, I'm going to make sure my ID is unique. Okay, and I'm going to go ahead and click commit. So I've added a new claim in my database. And if I go to my Excel sheet as a client, if I go ahead and refresh my table, right now I have 2 to 7. I'll have an 8th row show up. There we go. And if I look at my claim status, I will have a 2nd approved claim. And you can see the graphic automatically refreshing. Now, the authorization rule that I have in this particular demo does not do any particular checks on insurance claims. If you're a claims manager, you can view all the claims. Of course, I could have written conditions such as you can only view the claims in your region, you can only view claims that have not been assigned, so on and so forth. But right now, the claims policy is very simple from an ABAC perspective. We go back to my demo. If I add or remove a relationship, I will gain or lose access to data. Okay. If I go to my database and I go to my broker table, here in the broker table, I can see the relationship between different users and different brokers. For instance, you can see that Alice, my user, is assigned to Elsa as a customer. Here, what I could simply do is say, not Alice, and I'll commit it. So Alice will lose access to Elsa's record. If we go back to my, before we go back to my Excel, I need to change Alice's role and make her broker again. So go back to Alice, make her a broker. And we can go back to our demo. Now is not a good time to update Java, so we'll click cancel on that. We can go ahead and go to the insurance claims, hit refresh. We've lost data, we've lost access to the claims, we're not a claims manager anymore. We can go to the insurance policies, and you can see
that was because you changed the role, right?
Exactly. Yes. That was because I changed the role. And now if I go to the insurance policies, now we have data. We didn't have data a minute ago, we had 0 policies, but now we can view 2. But if you remember, Finn, earlier, we could actually see 6 or 7 insurance policies. Now we can only see 2, and those 2 policies belong to the customer called Maya. And Maya is the only customer I have a relationship with now, which is why we can only see her.
That's what you changed before, yeah.
Yes, I removed a customer-broker relationship. Now, one last item I can do, of course, is I can go ahead and close Excel. I'm not going to save. And I'm going to log off Alice. I'm going to go back to my PowerPoint, and I'm going to check the last scenario, log out and log in as a separate user, and see what happens. Well, we have a user, and I believe, at least last time I checked, she was a claims manager, so we'll see if she still is a claims manager. And her name is Julia, and her email, I believe, is claimsmng.com, and her password is a secret, and I'm in. I'm logged into my box, and much like Alice had to go ahead and double-click on the Excel sheet to see information, Julia will have to do the same. And here what we're going to do is we're going to go to our data, hit that refresh all button. And you can view, let me see, the updated data. So Julia is indeed a claims manager. She can view the claims. And if I go to my insurance policies, I cannot view any insurance policies. Okay. And if I go back to my claims by status, you can view the updated graphic with the 5 unapproved claims and the 2 approved claims as per the insertion of data we did before. Very simple demo that illustrates the relationship. Now, one last thing. What if there's an emergency? What if suddenly we believe the system has been compromised? Is there any way to quickly turn off all access? Well, yes, there is. We could upload a new authorization policy in our portal that would block everything. So let's do that. Here is the management piece of our SQL filter service, and I'm going to upload a configuration called deny. What that authorization policy says is deny everything, everywhere. I'm going to upload it, apply it, and if I go back to my Excel sheet, if I go back to my list of insurance claims, if I refresh all, I've lost access. I've lost access to absolutely everything. I cannot view any data of any table in my database, and it took me under a second to do that. It was instant. On that note, Finn, I believe, oh, before I hand it over to you, Finn, one more note is that, is there a backdoor? Well, no. So long as you put the proxy in front of the database as close as possible as you can to your database, and so long as you block off all the other ports that could potentially connect to the server where the database is running, as you would with firewalls and web application gateways, then no, there's no backdoor. It protects the entry point of your database as close as possible to what matters to you, your data, of course.
Right.
One more thing, as Steve Jobs would say, and I referred to that earlier, Finn. The demo here focused on the role of the user and focused on the relationship the user has with the customer, but we could have focused on other attributes, such as the type of device you're using, whether you're coming in from a corporate computer, a personal computer, a cell phone, a tablet, a phablet, you name it, we can do it. It could have been based on time. It could have been based on the location of the user. If the user is coming from a trusted country, then access is allowed. If they're coming from an untrusted country, then access is not allowed, so on and so forth. And we can even do authentication type. If you come in with a username password, show so much information. If you come in with stronger authentication protocols, say two-factor authentication, then show additional information. On that note, Finn, back to you.
Very good. Yeah, and back to the demo, the one thing that we discussed this a bit before we started here, David, I think this is interesting as well because it relates also to a field that in my experience is very often a problem in companies where you use BI tools. So in this case, Excel sort of goes directly onto the database. And typically what we see in many organizations where you struggled for years to get, your auditors keep complaining and you keep tweaking on the application layer until you finally manage to meet authorization requirements as auditors demand. And then one day management comes through and says, well, this is not good enough what we get with regard to reporting out of that tool. And some clever staff member then rapidly with desktop tools or with simple or advanced BI tools sort of whips up new things. And then we bypass all the authorization that we have, namely built into the old application.
Right. With ADAF, it's no longer possible because the protection is so close to your data.
Yeah, right. So it's WYSIWYG.
WYSIWYG. Happy dogs.
Okay. So it's context aware. We can use location, date, time, device type, all sorts of things. With this release, it's also multi-database enabled. So we, in this first release, support Microsoft SQL Server and Oracle. There will be more databases added later on.
Right. And we're talking about big data as well. Do you have anything you can share with us, Finn, on that?
It's so that's a question that we commonly get. And the more questions we get about different things, they will be put sort of on the requests log, and we'll see when we get there. So the first thing will most probably be yet another database, most probably DB2 or something like this. But definitely that is sort of in the pipeline as well further on. This solution is enterprise ready. It's fault tolerant. It has you can deploy this behind load balancers for high availability and so on. And of course, it uses standard XACML in its policies, which is very strong. If you think about, there are some competing technologies out there. You could possibly say, if you were to go to the private database, sort of VPS type of technologies, where you then also work with a fairly stale sort of and static proprietary language. So using a standards-based policy language is extremely important.
Actually, if I may insist on that point,
yeah.
Back 10 years ago, roughly, there have been attempts at solving data-centric security. A couple of examples are, of course, FGAC by MySQL and then Oracle. So FGAP is fine-grained access control. Of course, there's Oracle VPD, Virtual Private Database, which were great solutions, but they were only for those particular databases, only for MySQL, only for Oracle, and of course that limited the breadth of applications Now, going with a standard such as XACML means that not only can you protect any number of databases, it's technology neutral, but also you can protect other things, web apps, web services, applications, enterprise service buses, you name it, you can do it.
Right, yes, yes. And we've shifted from the technology configuration tool onto the corporate access policy level.
Right.
So where do the policies come from? Well, they come from business managers who say this is what goes in this organization, rather than an IT techie guy who can do very advanced little things inside a database that no one else understands. Right?
It's putting the business back into the driver's seat.
Right. Yeah. Yeah.
And on that note, shall we open up for a Q&A session?
Yes. Yes. I think that's we're. So let's see. We have a few questions here from the audience.
Okay. Fire away.
Let me see. I'm struggling with the interface here.
It's a generation thing, Finn.
It is, yes. Absolutely agree. Yeah.
Let me help you. All right. So, let's make that window a bit bigger. There we go.
So the first question we have here is about what we just talked about, database support. What databases do you support? And as we said, with this first release, it's Microsoft SQL Server and Oracle. More to follow, so stay tuned. There will be, and we hope to be able to add other databases fairly rapidly.
Right.
The proxy server that we use has a broader support, so the only thing that we need to ensure is that we have all the other components talking the SQL dialect of those databases. Not a big deal. But okay, so and here we have another question. If a database administrator is logged into the database and accessing it locally, will this still be able to apply the restrictions that should be applicable to them when accessing data, or does the local database use bypass those protections? Very good question.
So I'm going to do a demo.
Very good.
I'm going to prove the point. So the answer is the security applies no matter what tool you use to access the database, so long as you go through the proxy, of course, much like you would go through a firewall. So in this particular instance here, I'm back in my SQL developer, the Oracle tool, and I'm connected to my insurance demo database. And if you click on properties, you'll notice that I'm connecting on port 1521, which is the default port for Oracle. So I am directly connected to the database, and therefore no security applies. But of course, I could have shut down that port, put a firewall there, prevent anyone from connecting to 1521, and then in that case, the only port that would be available would be the port that is protected by the SQL proxy. So what I'm going to do is change to that port number. In this case, I believe it's 1525. Let me test the connection. And let me see. It might be because I have my deny policy in place. Or is it on a separate IP? I never remember. There we go. It was a separate IP. So now I'm on port 180. I'm sorry, on IP 180. The database is the proxy is sitting on a separate server rather, and I'm connecting to port 1525, which is the proxy.
And now, David, you still have the latest policy applied, which was a deny all, right?
Yes. So if well, not only that, but because I'm connecting as the admin user, and the admin user is neither a claims manager nor a broker, the administrator cannot see any data.
Right.
So two penalties for that, man. So if I go ahead and expand the insurance demo, I can go ahead and go into my tables, and look at that. I cannot even list the tables because everything is blocked. Everything. In this case, the way I've deployed my security, the way I've configured my proxy, the actual ability to list tables is even prevented.
Right.
But let's assume that I know the name of my tables. I can do select star from Scott. I think it was claim in singular. Let's go ahead and try that. If I run that, I get no data back. It's found the table, but I get no data back. I can try from policy, no data back. I can try from, I don't remember the other policies, users, I think. Now I get data back. So if I try to access the users table, I get data. Why is that? Well, the proxy is not configured to protect the user's table, so the policy that we deployed would not apply to that particular table.
Right. Okay. This is really cool. Thank you. That was a complete answer, David. We've had discussions with some customers around this as well. One area where we see a lot of our customers struggling is in the separation between development, test, and production. Mm-hmm. And very often today you see quite elaborate sort of setups in these organizations to enable developers to work on production data without revealing production data to them. Yeah. So you may have static data masking going through there, or all sorts of other things. So you sort of scramble the data for developers. And so one question that is coming up: would this tool help us to have developers actually work on production data to do these sort of things? And to a certain extent, I think we need to be absolutely clear that there will always have to be DBAs who have root access to databases. Right. Otherwise, that's clear. We cannot work with data, maintain databases unless we have that.
Absolutely.
Depending on what your setup, your environment, yes, there are a number of such privileged accounts, highly privileged accounts, that you most probably can protect this way as well in a production environment, and allow, for instance, developers to have a subset of demo data that they can access that resides within the production data. Without so you could simplify this development, test, production sort of separation a lot using this type of technology. Yeah. So we have. We're getting close to the end. One more question, David. Mm-hmm. What is the database proxy being used in this solution? So yeah, here this is a OEM component of the product. It's a component that comes from one of the leading vendors within the data masking field. So the SQL proxy that we had in the illustration is a somewhat modified version then, based on this, where the vendor that we work with there is Informatica, but the proxy that we have is a somewhat altered sort of version of it.
So we are talking about the piece in gray here, right, Finn?
Yes, yes. Okay. So it's a modified version of this, and whereas the SQL filter service is entirely an axiomatic space.
Right.
Yeah. Okay, so we're getting close to the end. We have one other question, David, and that is, how about performance? Will this heavily impact performance, David?
Oh, absolutely. Because since you want to protect your sensitive data anyway, performance does not matter. I'm pulling your leg. I'm pulling your leg. No, it will not impact performance, or it could potentially impact performance if the policies you have written, if your configuration is not correct. But what we have found with our current customers, and those are customers with highly sensitive data, very rich and complex data, is that there's minimal performance penalty, if any, and that the risk they would run otherwise is such that they would rather incur that minimal performance penalty rather than reveal data that they do not want to reveal. I don't know if with your other customers, Finn, you have additional experience you want to share from.
No, I think that is correct. The one performance penalty that you could have, of course, would be that since we do dynamically rewrite the SQL query, the ending SQL query may be a bit more complex for the database to parse. Of course, that could be the issue. But provided your database is indexed properly, that's matching these queries, that should not be a problem. We're getting more questions here. What about joins between tables? Can foreign key relationships be protected?
Yes, absolutely, absolutely. Any type of, or pretty much any type of SQL statement that comes from the application through the proxy and down to the database can be protected. Now, of course, one thing that you have to be aware of is that if you're exposing a view and the application is connecting to that view, what you need to protect is the view, not the underlying table.
But I think this is a very interesting question in two ways. Number one, if I have a relation between two tables, I could make not the data table that is being selected to be viewed, but rather the reference table could contain the data that is the condition for the viewing, right?
Yes.
So I could have the secret in the reference table,
yes.
And if this is secret, so even if it's not included in the view, it could potentially sort of control whether or not I see it. So that makes it extremely fine-grained with regard to the data model. Another aspect with the views, remember we looked before at the before we looked at the demo, we looked at some of the effects of some policies, and there we had one policy that returned nothing, an empty data set, right?
It was this one, I believe. There we go.
That one, yes. And this could, of course, be a different thing if we here had a outer left join, right?
Correct.
Then we would indeed see first name, last name, and amount listed for all the users, and the social security number simply being empty.
Correct, which is a way of achieving masking, as a matter of fact.
Yeah. So joins can be very, very useful in this context.
Yes, indeed. But this has been fun, Finn.
Yes, it has indeed, and I'm very, very happy to see this product also being released. We're looking very much forward to discussions with our customers. We have had beta testing customers during these last months. It's been a very interesting discussion that we've had ongoing with clients, and we hope, of course, to have more such discussions with new customers looking into this. So we're getting close to the full hour, David. Thank you very much for the demo.
Thank you, Finn.
And thank you, all our listeners who have been patient enough to listen to the very bitter end. Thank you. Before we end, did we have a slide on our upcoming webinars? We don't. We're stuck here this time, yeah.
Well, I think the SQL proxy list filtered them out, and you cannot see.
Yes. Okay. Sorry about that. So, but please visit our website to find out about our upcoming events. Then. Thank you.
Thank you, everyone. Bye now.